Hello everyone, welcome to Study Made Easy, a smart learning for a smartphone generation. Now today we'll be continuing our discussion on kinematics, and today I'm gonna speak on speed and velocity. Right? So what does speed and velocity actually mean? So let us define speed first. Now speed is a physical quantity that simply tells us how fast an object is moving. Right? Now, mathematically, speed is defined as the ratio of the distance traveled by an object, distance traveled by an object to the time taken. Right? Now, as you can see that since distance traveled is a scalar quantity, time taken is also a scalar quantity, therefore speed also has to be a scalar quantity, right? So speed is nothing but a scalar quantity. So what does speed actually give us? It simply gives us the number with which we are moving, right? It simply gives us the magnitude of how fast we are moving. Now, talking about velocity, velocity has the same definition as that of speed, but the difference between velocity and the speed is that speed not only gives us the magnitude of how fast we are moving, but it also gives us the direction in which we are moving, right? So velocity, since it gives both magnitude as well as the direction of the motion, velocity has to be a vector quantity, right? So it is a vector quantity. Now, how do we define velocity mathematically? Right? Now, mathematically, velocity is defined as the ratio of the displacement traveled by an object. We have displacement traveled to the time taken during the displacement, right? During this time taken, right? So this is how you define velocity mathematically. Now let us see some classifications of both speed and velocity. The first type I'm going to talk about is uniform speed. I'll be talking about uniform speed and uniform velocity. Uniform velocity. Now what do these both mean? Now when we talk about uniform speed, we say that when an object during its entire destination, or I can say during its entire motion, if it travels with a constant speed, we say that an object is having a uniform speed, right? So the key word here is that for a person to travel with a uniform speed, he should have a constant speed during its entire motion. The another definition of uniform speed is that for an object to have a uniform speed, he should travel equal distances in equal intervals of time, right? Now let me say that a person at A wants to go to B, and let me say the distance between A and B is 1 kilometers, right? Now during this 1 kilometer, if he travels with the same speed, we say that he is having a uniform speed. Now again, the difference between uniform speed and uniform velocity is that uniform speed is actually defined for distance, right? And uniform velocity is defined for displacement. For an object to be having a uniform velocity, he should have a constant velocity, right? He should have a constant velocity. That means he should have a magnitude as well as the same direction, right, during its entire motion. Now, it is also defined, constant velocity or uniform velocity is also defined as if a person travels equal displacements in equal intervals of time, right? I think it's very easy. I don't see much difficulty in understanding both uniform speed and uniform velocity. Now, the mathematical equation for uniform speed as well as for uniform velocity have been already discussed, and these are the equations for uniform speed, and this is the equation for uniform velocity, right? Now, having understood this, let's move ahead and talk about average speed. Let's talk about average speed and average velocity and average velocity, right? Now, what does average speed and average velocity mean? Now, let me mathematically define these two terms, and then I'll move ahead and I'll try and explain this to you. Now, mathematically, average speed is the ratio of the total distance traveled total distance traveled by the object to the total time taken right? Now, this is mathematically defined, right? Now, let's talk about average velocity. Now, average velocity mathematically is defined as the ratio of the total displacement traveled by an object. We have total displacement traveled to the total time taken in traveling the displacement. Now we have total time taken, right? So this is how you mathematically define average speed and average velocity. Now, to understand that why do we actually need average speed and average velocity, let's take an example, and let me say that a person standing at A wants to travel and go to B, and let me say the distance between AB is 5 meters, and the time he takes for its motion is, let me say, 2 seconds. And then after reaching B, he again moves and travels to point C, and let me say the distance between BC is 16 meters, and the time he takes is, let me say, 4 seconds, right? So if I ask you that what was his speed during AB, you would simply say that his speed would come out to be 2.5 meter per second. Similarly, his speed during BC would come out to be 16 meters by 4 seconds, and that would come out to be simply 4 meter per second, right? So here we can see that a person who wanted to travel from A to C actually did not travel with the same speed. Firstly, he traveled with the speed of 2.5 meter per second, and then he simply traveled with the speed of 4 meter per second, right? So here we can see that we can't have a single value for our speed or velocity in our journey. So therefore, it is necessary to talk about average speed and average velocity so that it would give us a rough estimation of how fast we have moved, right? So average speed and average velocity simply gives us the rough estimation of how fast we have moved during our journey, since our velocity or speed was not constant. Now let's move ahead and talk about instantaneous velocity and instantaneous speed, right? And instantaneous velocity. Now, instantaneous speed gives us the speed at a particular time, or I can say at a particular instant, right? Now, the best example is that suppose you want to travel from one point to another point, and if you are interested in knowing what your speed is at a particular instant, what would you do is that you would look at your speedometer. Now the speed which your speedometer would give at that instant automatically gives you the instantaneous speed at that time, right? So instantaneous speed mathematically is defined as ds over dt, where this s stands for distance traveled. We have distance traveled, while instantaneous velocity, I can write here, instantaneous velocity is ds vector by dt, where this s vector stands for displacement traveled. Displacement traveled, right? Now, having understood this, let's move ahead and talk about a problem that we are going to discuss now, right? Now, let me say the problem. The distance traveled by a person in time t is given by this, right? So this is the distance travel. This is an equation of distance traveled by a person. Now, what we need to calculate is, firstly, we need to calculate the average speed of that person during 0 to 5 seconds, right? So let's talk about our A part. Now we want to know the average speed, right? Let's talk about the average speed. The average speed was defined as the total distance traveled by an object by the total time taken, right? So it was total distance traveled by total time. Now we know from this that the time he took for its distance was simply 5 seconds. So he travels only for 5 seconds, right? So total time comes out to be 5 seconds. Now the distance traveled in this 5 second can be calculated from this, right? We have an equation for distance, and that is d is equal to 2.5 meters per second square into t square, right? So substituting the value of 5 seconds here, I would simply get the distance he has traveled during 5 seconds. So d comes out to be 2.5 meters per second square into 5 square becomes 25, so it is 25 second square. Now this second square and this second square cancels out, and the distance traveled during 5 seconds comes out to be simply 2.5 meters into 25. Now this comes out to be simply 62.5 meters, right? So this is the distance traveled by an object. Now let's try and calculate the average speed. So the average speed, so the average speed comes out to be simply 62.5 meters by 5 seconds, and that comes out to be 12.5 meters per second, right? So this is our average speed with which a person is traveling, right? Now this gives us the rough estimation of how fast he is moving. Now the second part of the question says that calculate the instantaneous speed at t is equal to 5 seconds, right? So we have already written the formula for instantaneous speed, and that is instantaneous speed is nothing but ds over dt, and here our s is nothing but 2.5 meter per second square into t square, right? So if I differentiate this equation with respect to t, I'll get my instantaneous speed, right? So differentiating this with respect to t, I'll get ds over dt, and that would come out to be 2.5 meter per second square into 2t, right? Now we need to calculate the instantaneous speed for at t is equal to 5 seconds. So I'll substitute the value 5 for t, and I'll get ds over dt as 2.5 meter per second square into 10 seconds. Now this s and this one s cancels out, and the instantaneous speed I get is simply 25 meters per second, right? So this is our instantaneous speed. I hope that you have understood this problem easily. I think this is enough for this video. I'll see you in the next video. Till then, take care and study smart.